Okay, now that we've talked about the different parts of a parabola, we're going to practice graphing the parabolas. And the function that we use is a quadratic function. So this is called graphing quadratics in standard form. So remember that standard form looks like ax squared plus bx plus c. And that's where we get that standard form from. We're going to start with just graphing ones that look like y equals ax squared. And the very first one we're going to graph is y equals x squared. Now we know from Unit 1 that y equals x squared, this is our parent function. And so it starts at 0, 0. That's where its vertex is going to be. And when we're graphing these, we always want to start out by figuring out where is the vertex. So if it's just y equals ax squared, our vertex is always going to be right at 0, 0. Because we learned in Unit 1 that if nothing's added or subtracted to it, then it hasn't been translated left or right or up or down. It's still sitting at 0, 0. Now to get the other points, we're going to plug in some numbers. I'm going to plug in 1 and 2 on this side, and -1 and -2 on this side. And we're just going to plug them right in for x squared. So when I plug in a -2 for x, I get -2 squared, which is 4. When I plug in a -1, -1 squared is 1, 1 squared is 1, and 2 squared is 4. The next thing I do is I go to my graph, and I'm going to plot those ordered pairs, starting with -2, +4. So we're going to go over 2 and up 4. Then we're going to graph -1, 1. So left 1 and up 1. We've already graphed 0, 0. So we graph 1, 1, right 1, up 1. And then we're going to graph 2, 4. So we're going to right 2 and up 4. And that's enough points to give us the shape of our parabola. And so we're going to connect the points. We know that it's kind of a rounded shape. So be careful down there at the bottom that you make it look rounded. Okay, so we have a vertex here at 0, 0, which is one of our questions, one of the characteristics that we're looking for. So we'll go ahead and put that in. It also asks for the axis of symmetry, which we talked about in the parts of the parabola video. So we have this line of symmetry that goes right through the middle of the parabola. And since it's a vertical line, we know it's going to be x equals, and that line is at x equals 0. So our axis of symmetry is x equals 0. Okay, now we're ready to talk about domain and range. So we know that the domain for quadratics is all real numbers. But the range we have to look at a little more closely. Remember, we want to look for a lowest point or a highest point. So for these, we're going to be looking at the vertex, and the vertex is the lowest point, and all of our graph is above that point. So all of our y values are greater than or equal to 0. Then we want to look at the increasing and decreasing. So remember, increasing and decreasing, we said we read the graph from left to right. So if we start on the left, this graph starts out decreasing, and it decreases all the way down to the vertex. And the vertex, x has a value of 0, so it's decreasing where x is less than 0, and then it's increasing for everything to the right of 0, so it's increasing where x is greater than 0. When you're looking for increasing and decreasing, it's a good idea to use the axis of symmetry as your guide, because the axis of symmetry divides it right down the middle, and it's going to be increasing on one side of it and decreasing on the other side of it. So I'm going to get rid of some of these. I'm just going to sketch it back in. It got a little messy with all of the arrows, so there we go. All right, our next example, we have a y value, an a value of 1/2. So we know that that 1/2 means that it's a vertical. Is it a shrink or a stretch? It's a shrink. we know that the fraction values give us a shrink, and then large values make it a vertical stretch. Since it's still in the form y equals something times x squared, but nothing is added or subtracted, we know that our vertex is at 0, 0. So we're still going to put that 0, 0 in here. And then I'm going to pick 1 and 2, -1 and -2 for my points on either side, or for my x values anyway. And now I'm going to plug those x values in. Remember that we do exponents before we do multiplications. So for this, you're going to do 1/2 times x squared. Be sure you do the x squared part first. So -2 squared is 4, and 4 times 1/2 is 2. -1 squared is 1 times 1/2 is 1/2. 1 squared is 1 times 1/2 is 1/2. And 2 squared is 4 times 1/2 is 2. And then we're going to plot each of those ordered pairs. -2, 2. -1, positive 1/2. 1, positive 1/2. And 2, 2. And we can see that if we compare this graph to the graph we just made, we see that it's wider. That's how we can tell that it's a vertical shrink. Okay, so let's talk about the characteristics. We said the vertex was at 0, 0, and the axis of symmetry still going right down the middle there. So that's at x equals 0. The domain, it's a quadratic function, so the domain is all real numbers. The range, again, the vertex is sitting right there at 0, so the range is everything where y is greater than 0 or equal to 0. Increasing, again, it's increasing kind of the same as it was for the last one. It's increasing to the right of the axis of symmetry. So it's increasing where x is greater than 0, and it's decreasing where x is less than 0. You'll notice on the increasing and the decreasing that we don't say greater than or equal to. We also don't say less than or equal to, because right where x is equal to 0, that's the vertex, and it's not increasing or decreasing at that point. That's where it's changing direction. Okay, we're going to do one more example that looks like y equals ax squared. For this one, we have an a value of -3. And we know that that tells us two things. It tells us, one, that it's going to be a vertical stretch. And also, since it's negative, we know that the graph is going to open down. So it's going to open down, and it's going to be a vertical stretch. Okay, since it's at 8, it's just y equals ax squared. Again, the vertex is going to be at 0, 0. So we start by putting our vertex right here in the middle of the table. We're going to plug in the same values we've been plugging in. And we're just going to plug them in for x squared. Remember to do x squared first and then multiply by -3. So -2 squared is 4 times -3 is -12. -1 squared is 1 times -3 is -3. 1 squared is 1 times -3 is -3. And 2 squared is 4 times -3 is -12. And we're seeing a lot of symmetry in these tables, and that's exactly what we saw in Unit 1 when we were looking at the tables, was that same kind of symmetry. So let's go ahead and put our vertex at 0, 0. Now the point -2, -12 is well off our graph, so we're not going to plot that one, but we will plot -1, -3, and +1, -3. And we see both that it got really narrow. That's because this is a vertical stretch. And we see that it's a reflection in the x-axis. Pardon my handwriting here. This is a little difficult. A reflection in the x-axis. Okay, our vertex is at 0, 0. We see again that our axis of symmetry is right here through the middle where x is equal to 0. So x equals 0 is our line of symmetry. I'm having a little trouble with my pen again. Let's see. X equals 0. Perfect. Now our domain, still a quadratic, so our domain is all real numbers. Our range, this time we have a highest point, we have a maximum instead of a minimum. So all of the y values are below the point 0, 0. So our range is y is everything less than or equal to 0. Now increasing or decreasing, we know we divide it by the line of the axis of symmetry, and we read from left to right. So for this one, it's increasing on the left-hand side, so that's where x is less than 0, and then it's decreasing on the right-hand side where x is greater than 0. Okay, let's put together all of this information right over here. It says understanding this equation. So what happens, let's first talk about when is it a shrink or a stretch. So we know that it's going to be a shrink if it's anywhere between 0 and 1. But also, between -1 and 1. So if your a value is anywhere in here, then your graph is going to be a vertical shrink. And then we have the stretches. It's a stretch if a is greater than 1. And it's a stretch if a is less than 1. But when a is equal to 1 or a is equal to -1, then that's when we know it's going to be the same shape as the parent function. We know that at that point, there is no shrink or stretch. Oops. Let's see. Let's make that red. Okay, that's what happens when a is equal to 1 or -1. So what happens when a is positive? That's when our graph opens up, and we know it has a minimum value because its vertex is at the bottom. Now when a is negative, that's when the graph opens down and it has a maximum value. We'll just go ahead and draw a sketch next to each one of those. If it opens up, then it has a minimum value. If it opens down, that's when it has the maximum value. Now, where is the vertex in the equation when it's y equal, oops, too many n's in that sentence. In the form y equals ax squared, that's when our vertex is going to be at 0, 0. These are going to be the easiest ones for us to graph because it's always going to be right at 0, 0. And then the axis of symmetry for these, since the vertex goes through 0, 0, the axis of symmetry is always going to be x equals 0. Now when we start moving the function around, it's going to take a little more work to find those pieces. But when it's in the form y equals ax squared, we know the vertex is sitting at 0, 0, and the line of symmetry goes right through the middle at x equals 0. All right, in the next video, we're going to cover graphing when it's ax squared plus c.